Compound probability. Compound probability sounds like in elementary school when you learned compound words the first time. Doghouse, playground, basketball. What's another one?
Volleyball.
Baseball, volleyball. Okay? And you try to impress your teacher by coming up with the coolest compound word. That's what I remember. I was so excited when I could figure out my first one for some reason when I was a little girl. Compound probability is very similar. It's taking two things, two events, more than one event, more than just rolling a die. We're looking at doing rolling a die and a spinner. Or we could roll a die, spinner, toss a coin. Okay? We're doing more than one event. So, what I want you to write is this definition underneath your title of compound probability. Compound probability, the probability of multiple events, two or more. The neat thing is that you've already noticed is that if you have multiple events, you multiply. So you find the probability of the first event, get the fraction. Find the probability of the second event, get the fraction, and you multiply those to get your answer. Okay, there are a few key words that you need to look for in order to know when it's compound. You ready? Put keywords. Keywords. That's a compound word. Keywords. Here are your keywords. And. 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 And is a keyword. Then. 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 So and. Then. And the last thing to look for is not a word, but it's a grammar. It's a piece of grammar. One of your marks that you use in grammar. Commas. So you're looking for and, you're looking for commas, and you're looking for then. Okay? Those are your key words or key things to look for to know if you have to get fraction and multiply. Can we have 4 events? Can we have 5 events? What if I have 4 events? How many fractions would I multiply? 4 of them. If I have 5 things going on, how many fractions do I multiply? 5 times. So I multiply 5 fractions. Okay. Now, pencils down. We're just going to look at a couple of these, okay? Number 1, how many events are going on in this probability experiment that you see before you? How many events? We're doing a number cube and a spinner, right? We've got 2 events taking place here. So we have 2 events. We have a number cube and we have a spinner, right? So how many fractions are we going to have for each one? 2 fractions. Okay, number 1, P does not mean percent. P means probability. So what's the probability of rolling this cube and getting a 2? And, there's that word and, the probability of getting a yellow on the spinner. So we start here. What's the probability of rolling the cube and getting a 2? Getting a 2. 1 what? Out of 6. It has to be a fraction. Times. What's the probability of spinning and getting yellow? 1 over 8. 1 times 1 is? 6 times 8 is? Look at that. A 1 out of 48 chance of getting both of those. Is that likely to happen? 1 out of 48? Huh? No, it's not even a half chance, is it? No, that's probably not going to happen. You're probably not going to roll and get a 2 and a yellow. 1 out of 48 is not big at all of a chance. Okay, next one, number 2. The probability of getting a 3 and then blue. So what's the probability of 3? 3. What's the probability of 3? I heard somebody say 3 out of 6. There aren't 3 3s on a number cube. That's not correct. What's the probability of getting a 3? 1 out of 6. There's only 1 3 on a number cube. Then what's the probability of blue? 3 out of 8. Okay, now we multiply. 1 times 3 is? 6 times 8 is? Is this likely to happen? Nope. 3 out of 48 is not a lot of chance there. Can I reduce that? Yes, and you should reduce. Okay, next. The probability of getting an even number. How many numbers are even on a number cube? 3 out of 6. And the probability of red. 2 out of 8. We multiply, we get 6 out of 48. Is this likely going to happen? Even if we divide this out by 6, that's 1 out of 8 chance. That's not a lot. Okay, next, let's do prime. Probability of prime and not purple. What numbers are prime? 1 is not prime.
2, 3, and 5.
2, 3, and 5 are prime. So how many numbers would that be? 3 out of 6 times. What about not purple? How many are not purple? 7 out of 8. Okay, 7 times 3 is, and 6 times 8 is 48. Is that a big chance of happening? Are we getting close to half maybe? What would half be? 24. So we're around the 40% here of happening. Okay, what about number 5? A number and a color. What's the probability of a number? 6 out of 6. Probability of a color. So what will that be?
Okay, out of 48.
Is that definitely going to happen? What percent would that be?
100%.
100%. That's definitely going to happen. Yeah, if you roll this, you're going to get a number. If you spin this, you're going to get a color. What about number 6? Probability of getting a 4. 1 out of 6. Probability of getting a pink over here. 0. Anything times 0 is? It's impossible. You can get a 4, but you can't get a 4 and then spin and get pink. That's the problem. You can't do both because there's no pink. That's why 0. A number greater than 2. How many numbers are greater than 2 on this number cube? So 4 out of 6, and then not red. 6 out of 8, which gives us 24 out of 48. What percent is that? 50%. All right, you're going to solve 1, 2, 3, and 4 on your paper at this time, and then we'll go over them together. All right, here we go. The probability of heads and blue. What's the probability of heads? And blue, which gives us 2 out of 12, which reduces to 1 over 6. Is that likely to happen? Nope. Number 2, probability of tails. 1/2 yellow, which is 1. Is that likely to happen? Okay, number 3, probability of not tails. That means heads then. What's the probability of heads? And then not green. And we get 5 out of 12. We're getting close to half on that one, aren't we? Okay, number 4, not heads. That means tails then. 1/2, and then pink, which equals not possible to get both. All right, that was yesterday's work that you did.